This just in, nuclear fusion occurs in the stars including our Sun and accounts for all our energy output.
This process contains hydrogen nuclei similar to protons to produce helium.
Our main focus for today includes nuclear fusion.
Because nuclear fission only occurs in heavy nuclei such as uranium-235 and plutonium-239.
For stars with eternal temperatures less than 15 million Kelvin, the dominant process is proton-proton fusion. Proton-proton fusion is common in the Sun and other stars. Basically, two protons fuse, one of the protons is transmuted to a neutron, which forms deuterium. Then the deuterium fuses with another proton, followed by the fusion of the two resulting helium nuclei. An alpha particle then forms with the energetic release of two protons, thus completing the proton-proton fusion cycle.
For older stars that are beginning to collapse at their centers, the temperatures can exceed 100 million Kelvin, thus initiating the helium fusion process called the triple alpha process. More common in later phases of red giants and red supergiants. The triple alpha process can fuse helium to form beryllium and then into carbon.
This leads up to our final topic for today, the carbon fusion cycle.
The carbon fusion cycle is the dominant mechanism for larger stars with higher internal temperatures.
The carbon fusion cycle is not a significant part of the Sun's fuel cycle, so why do we care?
Well, stars like Sirius, with a mass more than twice the Sun, derive almost all of their energy from the carbon cycle.
In these stars, the central temperature is greater than 15 million Kelvin. Carbon fusion is thought to take a dominant role over hydrogen fusion.
The biggest part of the carbon cycle is adding protons, but after a carbon-12 nucleus fuses with a proton to form nitrogen-13, one of the protons decays, emitting a positron and a neutrino to form carbon-13.
Two more protons produce nitrogen-14 and oxygen-15. Another neutron decays, leaving nitrogen-15.
And another proton produces oxygen-16, which emits an energetic alpha particle, returning it back to carbon-12 to repeat the cycle.
This last reaction is the main energy source in the cycle for the fueling of the star.
Now we have learned about the most common nuclear fusion and learned about the fission that the Sun and the stars produce.